So let me hit record and put those in one more time. But yeah, if you missed that, we just watched the second one where you, how to find the center of dilation. So there are both of the links for you in case you missed them and want to watch them later and are having trouble with them. I will also grab, this morning Anthony and I went over 3.02. Let me put that tutor-time recording in the chat. So 3.02 went over dilation. If you're having trouble with that, you might check out that recording that I just put in to see if that might help you on a couple questions. I can't remember, Anthony, which ones we went over. I think it was 1 and 2, right? Question 1 and 2 on that quiz. But anyway, that brings me back to just to remind you guys, hopefully you saw that announcement, that tutor time today, I moved it to 9:45 this morning. So if you need to come to tutor time, we had that already this morning. But if you didn't see that announcement, you really, really need help, let me know, and I will help you. I just can't do it right at noon like usual, but I'll get you the help you need one way or the other. All right, so let's go to the next page, and we're going to talk about lesson 3.03 and 3.04 today, because we did 3.01 and 3.02 Monday, and so this will put you through the end of the week. And we're going to cover questions 3, 4, and 5 on the quiz. Okay, so one thing that you'll want to know for 3.03 are 2 vocabulary words, means and extremes. Mean is the middle value of a group of numbers, so that's the same meaning that it's had forever in math. You've probably gone over mean before. But extremes are the outsiders. And where that really comes from is if you have a fraction, two fractions with an equal sign between, and you multiply them, we cross multiply in that case. Or if you have a ratio, you can see how the means and the extremes are related there. Okay. Well, you're right, Devin. So mean is, you're right. It's not quite the same. Mean is more like the average. So you're finding, yeah. So I guess we don't want to get too, I wasn't trying to say it was the middle number in a group of data, because you're right, that's the median. Mean does give you approximately what's in the middle, but we do calculate it a little differently. So in 3.03, you're not actually going to have to do any calculations to find the mean like you would before. What I was trying to say is just like an analogy to think about what mean is referring to as kind of the middle of a group of data. So that's what I'm saying there. Yes. Sorry, Devin, but that's a good point, because I don't, the way I said it, I might have confused you guys. So I'm glad you brought that up, because I don't want to mislead you. So that's a good point of clarification. Yes. Okay. Well, you're not saying B equals C. No. This just, the B and the C are called the means, but we're not going to say that B equals C necessarily. So let's get into 3.03 a little more, and you might see how those will be used. So question 3, which of the following statement indicates that parallelogram QRST is similar to parallelogram DEFG? Okay, so this doesn't have anything to do with means and extremes. This actually has to do with knowing what the symbol is for similar. Remember how in semester 1 we went over congruent a lot, and that was an equal sign with a little, it's called a tilde or a squiggly, the fancy technical term for it, but we had that above the equal sign, and that stood for congruent. So this would say rectangle QRST is congruent, or parallelogram QRST is congruent to parallelogram DEFG. Which one do you know so far in your studies? Do you know which one means similar? And if you don't, that's okay, because that's what you're in here for, right? Nobody knows? It's just, okay, Devin's typing. Devin might know. Oh, no, Devin doesn't know. It's just the one squiggly. like that. So that is our symbol for similar. Just, yep, you got it. A is the one we're going for. Okay. All right, so this sort of goes with the means and extremes as far as just seeing that you are going to have a lot of proportions here. Hey Mason, sorry, it looks like you're getting kicked in and out of this session today, but we're recording it, so just in case you get kicked out, can't get back in, it'll be there for you. Okay, so it says if triangle RST is similar to triangle WXY, which of the following is a proportionality statement for the ratio of the sides of the triangles? Well, first, let's back up just a second. I'm just going to draw a couple triangles here. We haven't exactly talked about what similar means yet as far as the shapes go, so let's talk about that real quick. So let's just call this triangle RST and triangle WXY. If these triangles are similar, so it does say that they are similar in this problem, it tells us RST is similar to WXY. That's not a very good symbol, but that's similar. What that means is that the sides are all proportional. So remember how I just got done talking about congruent? We talked about that a lot semester 1, right? And if two triangles were congruent, what did that mean about the sides and the angles? Good, Mwada. You're right on track there. What did congruent mean, though? So we're going to just compare and contrast congruent versus similar. So first semester we talked a lot about congruent. What did the symbol congruent mean? Yes, same size, same shape. So all of the sides were equal, and all of the angles were equal. Okay. Now that we're talking about similar, I'll delete this. Need to make that a little bit neater. It's driving me nuts. There we go. That's a little bit better. So if we're talking about two figures that are similar, I don't know if you guys saw what Mwada typed in the chat, but she's right. Similar means the same shape but a different size. Okay. Now what that means as far as the sides, it means that the sides are proportional. And this goes to the scale factor that we've talked about in 3.01 and 3.2. So you can take different pairs of sides and they're all going to reduce down to the same fraction. Okay, so proportional. The angles are still going to be equal. So that's sometimes a little surprising. At first you think that the angles might be proportional as well, but the angles are still equal. It's just that the sides are going to be a little bit different. They're going to be proportional rather than equal. Okay? And yes, a lot of you guys are getting option D even without knowing the background of the difference between congruent and similar, because you're just looking at the fractions and matching up the right letters, which is good. And we did get that practice when we talked about congruent, right? When we had like side, 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 and side angle side, I said you got to make sure you match up, or if we were just saying this triangle is congruent to this triangle, we had to make sure the vertices matched, right? So that's the same idea here. If we look at my drawing, you have RS over WX, so you want to make sure those are the same sides, RS, WX, yep. And even if you don't have the drawing, you can look at the names of the triangles to get that. Okay, so we can say, grab a different color. Oh, it's changing to highlighter. I don't want that. Okay, so we could say RS is the first and the second letter, WX is the first and the second letter, so those are going to be corresponding sides. Or S and T are the second and the third letter, so we want to make sure that that's matched up with WY. Okay, does that make sense? So we kind of covered lots of different, hit on different things there. But you guys are right, as far as setting up proportions, you're just looking for matching letters is really the key there. But we kind of also dove into what similar means. Okay, but you can see that this is getting at that scale factor idea. If you have a fraction, it's going to be, you know, you might have 12 over 4, which reduces to 3, and then these sides might be 3 and 1, and that still reduces to 3. Okay, so the ratio of each side, the corresponding side should be the same if it's similar. All right, question 5. So we're going to use that idea here. We want to figure out which one of these is not similar. Okay, so here's a couple triangles, a couple rectangles, more triangles, more rectangles. We want to figure out, using those proportional sides, which ones are going to be similar. Now it does tell you here all angles are congruent, and these are rectangles, so if they're rectangles, the angles have to be congruent, right? Because by one of the properties of a rectangle was all 4 angles are 90. So these have to have the same angle. So we have the angle part checked off, but you do have to check both things. So if you're talking about similar, you do want to check those both things. Are the angles equal? And are the sides proportional? So the angles are equal. We do know that part. We're really just concentrating on the sides to answer this question. So what would I do? Any ideas? Anybody want to grab whiteboard tools? I'll give you, maybe somebody could take A, somebody could take B, somebody could take C, and somebody could take D. Yeah, well, that's a very good thought there, Devin. Yep, definitely would make sense, right? Because if they're congruent, all the sides are exactly the same, all of the sides would be proportional as well, right? Yes, you know, and I don't remember actually which. Let's try. Let's give this a try. This would be a good, good thought there, because there might be more than one right answer if maybe some of these others here are also proportional. So let's give it a try. Okay, go for it, Mason. Let's see. Yeah, you already have whiteboard privilege. So Mason, you try option A and get us started there. And then Devin, do you want to show us what you're talking about in option C? Show us how you'd know that those, because they're congruent, that they're also similar. Anybody want to try option B or option D? Write out the work there. I'll do option B. How's that? I know you guys are probably looking at those and you see the fractions. It gets a little scarier. Okay, awesome material. How about you try option D, and I'll do option B. Okay? Hopefully you guys have enough room there. So I'll talk mine out, and hopefully this will be the same for the other 3 of you. But I'm looking at the 12 and the 4/3, or, well, I don't want to put tick marks on there because they're not the same. But what I want to do is make a fraction out of those. So I could do 12 over 4/3, and I'm going to simplify that fraction. So remember, if you have 12 is really a fraction, 12 is 12 over 1. So I have a fraction over a fraction, or a fraction divided by a fraction. Do you guys, I don't know if you've heard of this before, but I know I teach this to remember the rule is copy dot flip. So you can copy the first fraction as is. So we're going to copy 12 over 1. We're going to put a dot. We're actually going to multiply instead of divide, because we're going to flip this bottom one over. So instead of 4/3, it's going to be 3/4. Okay? And you can cross cancel before you multiply. 4 goes into 4 once, and 4 goes into 12 3 times. So I can rewrite this as 9 over 1, or just 9. So that's what the 2 blue sides reduce down to, if I made them into a proportion. Now I'll do the 4 and the 2/3. See if I get the same thing. So 4 divided by 2/3. Again, 4 is a fraction. I could write it as 4 over 1 over 2/3. So 4 divided by 2/3. I can copy the first fraction, 4 over 1, dot, and flip the 2/3 over. Instead of 2/3, I'm going to write it as 3/2. And I'm going to reduce before I multiply. So 2 goes into 2 once, and 2 goes into 4 twice. So that would give me 2 times 3 in the numerator, which is 6, and 1 times 1 in the denominator, which is 1, which gives me 6. So I'm actually looking to see if these match. Okay, so that's what it means to be proportional. If all the sides are proportional, it means if you make a proportion out of them, proportion is really just another word for fraction. Did you guys know that? It might be helpful. Okay, good. Amelia, yeah, Amelia knew that. So I'll write this in parentheses. It just means that the fractions are equal. Okay, so that's what proportional means. All right, so let's see what Devin's getting and Mason's getting. And then we'll come back to mine. Okay, so let's see. Mason is saying, okay, yeah, and this does get a little difficult sometimes to see which sides match up. You got to really look at the figure. But the 1.5 and the 3 are the sides that match up. So that's why he's saying 1.5 is 1/2 of 3. Okay, so yep, that's one way to think of it. And 1.12 matches up with 1.14, or excuse me, 2.24. And so he's saying, well, 1.12 is 1/2 of 2.24. So he's figured out that the side lengths of this smaller triangle are 1/2 as much as the side length of the larger triangle. So 1/2 is what all of the sides reduce down to. And so we could say, yep, option A is similar. So we'd say yes, those two triangles are similar. Okay. All right, let's take a look at Devin. Devin didn't write his out, but he's saying, well, it's so obvious we don't even need to write it out. But just so you guys can see what Devin's point is if they are congruent triangles, they are also going to be similar, because if you put 1.41 over 1.41, remember how any number over itself is 1? And you're going to get that same thing if you put 1.12 over 1.12. That's going to reduce down to 1. Oh, that's okay, Devin. I know. It gets, especially when you're writing with your mouse, it's hard to write small. So it's okay. I understand that. But they are going to all reduce down to 1. So on option C, we can say, yes, those two triangles are similar. All right, let's take a look at Atiro over here. He did his kind of similar to the way Mason thought of it. He said, well, if I take 2 and I multiply by it, yeah, it's similar but different. I like this. So we all did it a little bit differently. And all of these are great ways to think about it. They all work. So he figured out, okay, well, if I take 2 and multiply it by 2/3, if it's proportional, they should multiply to the same number. So I like that, Atiro. That's a good way to think about it. And that's actually easier, especially if you're getting into fractions. So you can see how I did copy dot flip. But you can certainly multiply them as well. If they come out to the same thing, then that would also indicate that they're proportional. So I like that. I like that idea. So we're going to say, yes, these rectangles are similar as well. So you could probably figure out, because remember our question is which of these are not a pair of similar polygons, and that goes to mine, right? Option B, because I got two different numbers when I made my proportions. Okay, so you want them to come out to exactly the same thing. Even if they come out, occasionally you will get decimals. So let's say one decimal came out to 2.25 and one came out to 2.24. They have to be exactly the same. So you would say in that case no. Okay, so even if you're getting decimals, they have to be exactly the same. So this one's going to be no, not similar. And so answer choice B would be our final answer here. That's the one that's not a pair of similar polygons. Okay, do you guys follow all that? I know that's a little bit confusing in one way because everybody did theirs a little differently. But I also kind of like it because it shows you different ways to do the problem. And Achiro's writing his method for my problem, so that would be fine. Yes, well, the means and extremes didn't really come in here. Really what we're doing on this problem is making sure that you match up the correct sides or the corresponding sides. And you can make, let me show you on Mason's. So to do the proportions or the fractions, because I was the only one that did that, I guess I did it the most straightforward way. And like I said, nothing is wrong with the way any of the other students did it. I actually really like some of your ideas there. But just to show you, sure, I could. Let me, yes. So let me point out real quickly before I erase the board what another option for my version. So I did the fractions. I matched up my corresponding sides. I said 12 and 4/3 are the same side of the rectangle, and I divided those or made a fraction out of them and reduced that fraction. So I got 9. And then I did the same thing with the 4 and the 2/3. I matched those up and I made a fraction out of them, and then I reduced it and I got 6. And so because I got two different things, I knew that was the option that was not similar. But Atira is showing you another way, you know, if you'd rather just jump straight to the multiplication part, you can also just multiply the corresponding sides together. And that, if you get that same number, then they're proportional. Here you're not getting the same number, so you can see they're not similar. But yes, I can erase the board. Let's see, let's do clear page. Yes, clear the page. Okay, so like for Mason's option A, what he was doing, but I can write it out a different way if you weren't quite able to see what he was doing in his head. If you pick the corresponding sides, so for example 1.5 and 3 are corresponding sides, you just want to make a fraction out of those two numbers, so 3 over 1.5. You could also do 1.5 over 3. So I get that question a lot. I get, well, how do you know which way to do it? And the answer is it doesn't matter as long as you're consistent. So when I pick the next pair of corresponding sides, so let's say I pick the 1.0, I meant to change color here. The 1.12 and the 2.24 are corresponding sides. You can, because I started with the 3, you know, if I'm going to do it this way and keep it consistent, you want to start with the 2.24 over 1.12. Or down here, you could do 1.12 over 2.24. Okay? So what I would do, most of you guys might not be able to see this as quickly as Mason did, which is totally fine. But at this point, what you would do is you would grab your calculator and do 3 divided by 1.5. Yes, thank you, Tara, for doing that. Hopefully, Anthony saw that before I erased it. So if I do 3 divided by 1.5, yep, good, Nathaniel, I get 2. Okay, now that you have your calculators out, do 2.24 divided by 1.12. 2.24 divided by 1.12. What do you get there? Yep, you get 2. Okay. And then we'd want to do the third pair. I didn't write the third pair up here yet. So keep the pattern the same. We're doing the larger triangle over the smaller triangle for these numbers. So I would do 2.82 over 1.41. So divide those. What do you get? 2, right? So you can see that all of these matching sides, the proportion that I created, or the fraction, is equal. They all come out to 2. Now, if you did it the other way, right, Devin, exactly. So that tells you that the sides are proportional. Now, if you had done it the other way around and you started with the smaller triangle and you put the sides of the smaller triangle over the sides of the larger, that's fine as well. Now, you are going to get a different fraction. So here you're actually going to get 1/2. So if you take your calculator, you do 1.5 divided by 3, you're going to get 1/2. Right? Try it out. If you, I'll give you time. Or you probably won't get 1/2 actually. You get 0.5 is probably what your calculator will give you, right? Which is the same as 1/2. But we'll write it as the decimal. Might be a little easier. So 0.5. Are you guys seeing what I'm doing here? What about 1.12 divided by 2.24? Yep, 0.5 again. And then my last pair of sides, 1.41 divided by 2.82. What are you going to get when you divide those? Yep, 0.5 again. So they're all the same. So that's what I'm saying here is that it doesn't matter if you do 3 over 1.5 or you do 1.5 over 3. As long as you're consistent with the rest of them, and then that answer comes out the same, you know, okay, yes, these sides are proportional. Okay? So don't worry about, okay, wait, do I put the larger over the smaller, or the smaller over the larger? If you're asked if the, polygons are similar, it doesn't matter. You're just looking to see if the fraction they reduce down to is all the same, because that tells you it's proportional. Does that help a little, Anthony? Or maybe anyone else that was confused? Okay, good. Good. Thank you for the question now. That's awesome. I love it, Amelia. All right, 3.04, numbers 3, 4, and 5. Okay, so now we're going to continue on with that idea. It tells us here triangle JKL and triangle MNO are similar. So we already know they're similar. So we know two things. We know the angles are all the same between these two triangles, and we know the sides are proportional. We want to know the side of OM. So you can see right here they put an R there. So what you can do, just like the last problem, we can think of it like this. We know that side OM over side LJ is going to be the same fraction as side MN over side JK because they're proportional. That's essentially what we did in that last problem, right? We found all of the matching sides and we said, okay, they all came out to the same fraction. Oh, sorry guys, that's why you keep typing it in, because I didn't change the polling to A through D. There you go. Now you can put your answer up there. All right. But does this idea here, does that make sense to you guys? You're just wanting to match up the sides, like OM and LJ, and that's going to be equal to another 2 pair of sides. Okay, and then you can plug in what you know. Now my biggest suggestion when I get to this, students will get stuck because, for example, let me write out that we have a 3rd pair of sides. So we could also say ON over LK. Those are all equal. Well, which ones should I pick? Because I only want to pick 2 of these 3. Because if I have an equation with 2 equal signs in it, it's like, what? What do I do with that? Okay, so we only need 2. So my suggestion to you guys is always start with what you're looking for and get that into your equation. Because then, because what I'll find is that a lot of students will pick these 2. Okay, then their idea is right. They're matching up the sides and they're saying, okay, these are proportional, so they're equal, which is true. But then they get stuck because they end up with 4 numbers. Okay, so the problem is then you don't get the side you're looking for into the equation. We need to make sure we have OM in our equation because that's what we're looking for in this question. Okay, so that's my suggestion is start with OM, say, okay, I definitely need this in my equation because otherwise I can't figure out what I need to know. Okay, so that's why we're going to concentrate just with these 2. So OM, you can keep it as OM or you can substitute in the R that they have right there. LJ is 6. MN is 2, JK is 5. How would we solve that? So we have 2 fractions with an equal sign in between. What's the easiest way to solve that? Good one. A cross multiply is the most straightforward, easy way. It doesn't matter if you do 6 times 2 first or R times 5 first. So I'll just do R times 5, which would give me 5R. 6 times 2 gives me 12. And then I want to solve for R, so I'm going to divide by 5. And so R would give me, what do I get there? Looks like you guys all have it. Yeah, most everyone that beat me to the punch got 2.4, which is right. Okay? All right. Let's try another one. Okay, now this gets a little harder. Now where this will get you guys, most of the time students can get the similar concept, okay, the geometry concept, but what will get you on these, I guarantee you, is your algebra, okay, because you'll start to see some x squareds in here. Let's see what I have on the next problem. Oh, okay, this is the last slide I have today for 3.04. But just remember, okay, and I do have some recordings. So if you get to an x squared problem and you're like, whoa, I don't remember from algebra how to solve this, check out my tutor time recordings list because I do have some on there where I've gone over that before. But don't forget about foiling. Okay, that's one hint to you guys. Just a preview. All right, so let's try number 4. I'm looking for side GF. So I'm going to put GF right off the bat into my proportion. What side is GF corresponding to? You guys all have whiteboard privilege. Yeah, type it in or point to it. So here's GF. You guys, does that make sense? It would match with CB? Yes, very good, very good. And so I'm going to, and this is also a tip to you guys, especially if you're struggling with this. Start with the letters first. A lot of students want to jump straight to the 2x and the 27. And if you're finding that you're doing that with no problem, go for it. But if you start to get a lot of these wrong, that's my tip, is take a step back and use the letters first and then plug in all your letters and numbers. Okay? So what else should I use? What else do I know? Go back. So in other words, up here in this other fraction, where am I going to get this information from? Can you guys tell me what would I have to use here? For example, could I use dA? Would I want to use side dA up here? Why not? Well, definitely one good reason is no info. What about even DC? I have some information about DC. Could I use DC up here? So I've used GF over CB. So now I want to fill in my other side. Could I use DC over here? Ah, Mwad, I got it. No, I actually can't. Okay, I don't want to use DC up here because you got to keep everything matched up. So you have to be very careful. Okay, it's very tedious, but you have to be careful. GF. Okay, let's color code. You guys know me. I like to color code. Let me back up a second. Let's color code here. Might make it a little easier for you guys to see why the answer to that is no. GF comes from this trapezoid. So when I go over here to my numerator, whatever I pick up here has to come from the trapezoid GF came from. So, good, I saw somebody type in HG or GH, yep, exactly. So I have to use HG or GH up here. Okay, I could use HE or EF as well, but I don't know anything about those, so that's probably a good hint that I don't want to go with those two options. Okay, all right, now let's go back down here. So see, I have green across the top because those are coming from this top trapezoid. So in the bottom, I need my side length here to come from this trapezoid down below. And it wants, I should have a side that matches with HG. Yes, good, Devin, you got it. So DC in the denominator. Or CD. Either way you write it, you're okay there. Yes. Okay, does that make sense? So the key thing with similarity is really a matching game. You have to match from top to bottom, and you have to match side to side. Okay? So that's why I really encourage you guys to start with the letters first, because it does get confusing. Now that we have all the letters in there, we can go ahead and plug in our numbers. So GF, if we look over there, is equal to 2x. Well, let's color code, I guess, while I'm at it. So I have 2x for GF and 4x, or let's see, HG is 24. So I'll just fill in my green stuff first. And then CB is 27 and DC is 4x. Okay, is everybody with me up to this point? Do you see how we got the letters for the corresponding sides? Everything matches up, and then I just went ahead and plugged everything in. Okay, good. Now, again, we have two fractions, equal sign in between them. How do we solve that? Good, cross multiply. So 2x times 4x would give me 8x squared. So don't forget about x times x being x squared. And then we want to multiply 27 and 24, which gives me 648. Okay, so here's an x squared problem. Now this one's probably about the easiest type of x squared problem you'll get. I want to divide by 8 first to get the x squared by itself. So I get x squared by itself because these 8's canceled. And 648 divided by 8 is 81. How do I get rid of that exponent of 2? Oh, good. Square root. Yes, you guys remembered. Nice. So square root, and I get x and 9. Is that my answer? Am I going to circle A? Anthony and Devin say yes. Oh, Mason says no. Nathaniel says no. Who's right? Oh, Amelia is changing her answer. Ah, they're throwing one of those geometry tricks at you. Remember that? How sometimes they try to trick you. Always go back and read the question before you click your answer choice, because you could totally have the concept down and then you don't go back and read the question and then they get you. So you have to plug it in, right? GF is not X, it's 2X. So you have to multiply 9 by 2 to get the correct answer. So if you chose 9, you were super close, but 18 is correct. Yep, B is what we want to go with. I know, close but no cigar. Okay? All right. Well, we are running out of time for question 5, but I think you guys can probably get it from here if you've understood everything up to this point. So give it a shot. Let me know if you have questions. But otherwise, I'll talk to you guys Monday. If you do have questions, like I said, today there's no tutor time at noon. But let me